For the first test, I'll have wired up 3 latches to use a single combined input to reset them. This test is to prove that the latch works and also to prove that a single 4.7K resistor will source enough current to switch 3 gates. I'm going to start with a visual inspection to make sure that everything is okay. Then I'm going to switch on the bench power supply and see what happens. No smoke is always a good sign. Because the latches will power up in an unknown state, I'll just need to reset it. Now I will set each of the 3 different call circuits. Right, that's looking good. Now I'll clumsily probe around for the reset terminal. Then I'll test again just for good measure. Well, I would call that a success. Next, a look at the basic circuits. We'll start with the call circuit. This circuit will be the same for car and hall calls, with just the inputs and output differing. This circuit contains only the set and reset logic, along with the indicator lamp. This part of the circuit takes the reset, direction and floor signal, then carries out an AND on them. This means that the reset signal will only reset the call if the lift is travelling in the correct direction and is on the correct floor. This input is for up, so this circuit would belong to the hall call up button and will only clear the call if it's travelling up. If this were a car call circuit, then this input will be left floating. This is because a car call is not directional. After all, the passenger will always get out regardless of the travel direction. This is the reset signal. It is generated elsewhere and is sent to all floor latch circuits. Each floor latch circuit then decides whether or not to reset itself. Lastly, we have the floor input. There is one of these generated by the floor selector for each floor when it has reached that floor. The floor signal is used for 3 things: floor indication, stop logic, and reset logic. Because these latch inputs are active low, I really needed to NAND the inputs rather than ANDing them. But I also needed to buffer the signal to ensure that it could drive the latch, so I replaced with the NAND with an AND and an inverter. Note the lack of a pull-up resistor on the collector. This is because its purpose is to sink current through a diode, so it doesn't need to source any current. This is a standard NAND latch SR flip-flop circuit. Here, the reset inverter is pulling the reset input low on the latch. And here, the call button is pulling the set input low. This is the floor lamp circuit. As the LED cannot be driven directly off the latch without affecting the operation of the latch, it has its own transistor to drive it. And lastly, this is just a buffer for the output to prevent any external connections from affecting the operation of the latch. Next is the stop circuit. There will be one of these for each call circuit. So here is the circuit. It's basically just an AND gate. Its purpose is to send a stop signal if it needs to service the current floor. This example is for up and will assert the stop signal if the hall call up for that floor is on, the elevator is travelling up, and the elevator is at this floor. The up signal is generated by the motor control circuitry for direction control. The direction control signals are used for 3 things: reset logic, stop logic, and direction control. The call signal that is generated by the appropriate call latch is fed in here. And here, the floor signal is fed in so that it knows it's on the correct floor. The stop signal is driven high through a diode and a pull-up resistor. The diode serves 2 purposes. Firstly, it prevents backflow. We only want the collector receiving current from its own pull-up resistor, so we can properly limit the current when it's pulled low. Secondly, we only want outputs to be able to send this signal high, never low. Next, we have the direction control circuits. There will be one of these for each floor, and this part of the logic is deceptively simple. Here is the direction control circuit. The switch to the right is the direction control switch for the floor selector. Each floor can send a signal above or below its switch. There is one of these switches for each floor, and they are all wired in series to form a ladder. The top of the ladder will have a signal if there are calls above the lift. The bottom of the ladder will have a signal if there are calls below the lift. The logic only checks these signals when the lift reaches a floor, so all of the switches remain closed most of the time. The switch opens just before the lift reaches a floor and closes just after it leaves the floor. When the lift reaches the floor and closes the floor switch, the contact for that floor in the ladder will already be open and the above and below signals will be valid. The above and below signals are processed by a mutual exclusion circuit to generate the up and down signals. This was covered in my first video. The direction control is basically just an OR gate. The three inputs are hall call up, hall call down and car call. This is where it gets confusing. When the lift is travelling up, the calls for a floor must get sent to the top of the switch, as the call signal routed below it will drop out before it reaches the floor, when the floor contact opens. This would stop the motor before it reaches the floor. The same rule, reversed, applies down. To work with this, we can use the up and down signals to control which side of the switch we route the signal to. This actually will not work though. That's because when the lift is parked, up and down are both off, low, so it will not route in either direction. To fix this, we use the inverted up signal for down and vice versa. This works because not up is down and not down is up. The main difference with this reverse logic is that when up and down are both low, the outputs will both be high and the signal will route in both directions. This could pose a problem if a hall call button were pushed when the lift was on the same floor, because the direction will be above and below with unpredictable results. If this were to happen though, setting the call would immediately trigger the stop circuit, as the lift has reached the floor that the call was generated from. This means that instead of taking off in a random direction, the doors should open and the call will simply cancel. Note that there are no inverters shown for the up and down. This is because they will need to be supplied through buffers, so the inverted signals will be taken from the buffers. Here is the first AND gate. If any of the call inputs are high and not down is also high, it sends a signal above the switch. Here is the second AND gate. If any of the call inputs are high and not up is also high, it sends a signal below the switch. And finally, we have the diodes that feed the signal to the switches. As with the stop outputs, these diodes are here to prevent backflow and to prevent the outputs from being pulled low. So let's now put it onto a breadboard and see what it looks like. So here is the result. It took some work, but it's built and tested. Here is the hall call up latch and reset circuit. Here is the hall call down latch and reset circuit. Here is the car call latch and reset circuit. Here are the testing switches. This is the hall call down stop circuit. Here is the car call stop circuit. This is the hall call up stop circuit. These are the up and down buffers and inverters. Here is the floor selector down circuit. Here is the floor selector up circuit. This is the OR gate for the floor selector. Here is the buffer for the floor selector. It goes between the OR diodes and the up down circuits. And these are just the LEDs. It uses a total of 38 transistors, 42 diodes, 6 LEDs and 65 resistors. Testing is very difficult as it is very unstable. Any vibrations would cause the connections to briefly jitter, causing failures. For this reason, I'm not going to video the testing. Next step will be to make up a set of proto boards that will make up each section of the design. These will be connected up to make much more stable set of boards so that an entire floor circuit can be put through its paces and properly tested. I will then be able to design a complete floor PCB and get a set made up by JLC PCB.